All right, in this video, we're going to be looking at lesson 1-4. Lesson number 1-4 is all about sequences. Now, in this box that you have in your notes, describes everything that we're going to need to know for this lesson. Now, I'm not going to be going through all of this all at once. I'm going to, as we go through this lesson, I'll keep coming back to this box. But the first thing I want to point out is, what is an arithmetic sequence? An arithmetic sequence is a sequence with a common difference. So a common difference just means that you would constantly be adding the same amount or possibly subtracting, because subtracting is just adding a negative number. So based on that description, let's look at these examples below here and determine which ones of those are arithmetic. So for the first one, I see that the sequence, so sequence basically is just a set of numbers that follows a pattern. And so here this sequence goes from 3 to 7 to 11 to 15 to 19 and then to 23. And it just keeps going. And we're just going to assume that it just keeps going at the same pattern. And if you notice, in this sequence, each to go from one term to the next, terms are the individual numbers. So the first term is 3, the second term is 7, the third term is 11, and so on. We are adding 4 each time. So to get from here to here, adding 4. To get from 7 to 11, we're adding 4. From 11 to 15, we're adding 4. So we're adding 4 each time. So that would be our constant difference. And so yes, that would represent an arithmetic sequence. Let's look at the next one. The next one goes 2, 4, 8, 16, 32, 64. Now for this one, if you notice, it is a sequence because we are multiplying by 2 each time, because 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and so on. But we are not adding the same amount, so no, this is not an arithmetic sequence. Now you might say for the next one, well, it's obviously not arithmetic because we're not going up, we're going down. Well, remember I said just a little bit ago that an arithmetic sequence, a common difference doesn't have to be positive, it can be negative. So to go from 100 to 93, we would subtract 7. From 93 to 86, I would subtract 7. 86 minus 7 would be 79, and so on. And so the difference here is that we are subtracting 7, or you can think of it as adding a negative 7. So yes, that does represent an arithmetic sequence. Now this next one obviously doesn't. It's alternating between -2 and 4, -2 and 4. It's a sequence, but it's a type of sequence where we're multiplying by -1 each, or negative, yeah, I guess not even doing that. So yeah, so we're just alternating between a +2 or a -2 and a +4, and so on. So this is not an arithmetic sequence. Okay, so now the next question is going to ask us to write a recursive formula. So let's go back up to the top here. We have two specific formulas. The first one we're going to talk about right now is our recursive formula. So what does a recursive formula tell us? Recursive formula first tells us what's the first term in the sequence. So that's the top row. The top row always defines what the first term is. Now, if you're wondering what this is all about, A is just we can give a sequence any name. Okay, so let's just say we use A for arithmetic sequence, but if we're dealing with a story problem, maybe dealing with the number of boxes that we have, you could use B as the name of your sequence. It doesn't matter. We could use any letter. And that number that's down below there, that we call that a subscript. That subscript is what we also call an index, tells us what term we're dealing with. So A sub 1 would refer to the first term of sequence A. Now what's this bottom row mean? Now in math, we have shorthand, or just like when you guys text, sometimes, a lot of times you use emojis or you use abbreviations for phrases, so you don't have to type the whole thing in. That's what we're doing here. A sub n minus 1 is something that we will always have in a recursive formula. That just references the previous term. Okay, so that represents the phrase, previous term. So we take the previous term and then add whatever your constant difference is. So D represents what we call the common or constant difference. For some reason I can't write. Here we go. So the only thing that gets changed here, that's going to be actual numbers, are those two colored circles, the A sub 1 and the D there. Those we would replace with numbers. All right, so let's see how we can write a recursive formula for these two. So the first one, it's just like the one that we saw up above there. In fact, both of these are just like the ones that we saw up above that were sequences, or that were arithmetic sequences. So now we're going to represent these with a recursive formula. So the way that we do that is we're going to start by defining what the first term is. So we say a sub 1, referring to the first term. The first term is 3. So that's all we do. That's our first row. It's that easy. Now a sub n just means to find any term in the sequence, this is what we would do. Or to find the next term in the sequence, this is what we would do. We would take the previous term, a sub n minus 1. And then we would add our constant difference. So again, going from one term to the next, we are adding 4 each time. So that's it. So if we didn't have that sequence listed and all we had was the recursive formula, we could come up with the sequence very easily because we would use our first term. Our first term is 3. Okay. And then this next row tells us how to find the next term. So we would take a sub n minus 1, in this case it would be 3, and add 4. So 3 plus 4 would be 7. So then we would take the previous term, which now would be 7 plus 4 gives you 11. 11 plus 4 gives you 15. 15 plus 4 gives you 19. So you see that that's how we would come up with that sequence using the recursive formula. All right, let's look at the next one together. I'll have you do some on your own in just a second. All right, so in the next one, we're starting with 100. Remember, this is the one where we're adding negative 7. Whoops, we're subtracting 7 each time. I can think of it as adding a negative 7. So when you do this one, we would start with your first term. The first term is 100. To find the next term, we would take that previous term. And then we could say plus a negative 7 or minus 7. I would accept either as your answer. That'd be your answer. That's your recursive formula. All right, so why don't you guys go ahead and pause the video and work on these next two. So your first step is to figure out whether or not these sequences are arithmetic, and if they are, write the recursive formula. If it's not an arithmetic sequence, then you can't do a recursive formula, in which case you would just say that there is none. All right, so go ahead and pause the video and hit play when you're ready to check to see if you've done it correctly. All right, so this first one, yes, this is an arithmetic sequence. We're subtracting 5 each time, so the first term is, it's 25. Find the next term, we would take the previous term and subtract 5. So again, the only thing that you're going to put in for numbers are in those two places here and here. Okay, now the next one is not a arithmetic sequence. Going from 2 to 4, we're adding 2. 4 to 7, we're adding 3. And then 7 to 12, we're adding 5. Okay, so it's not the same. So it's no constant difference or common difference that we have there between terms. All right, number 4 asks to write the explicit formula. All right, so the first one that we looked at was the recursive formula, and now we're dealing with an explicit formula. Now, what's the difference? A recursive formula is nice if we want to find like the first 4 or 5 terms. But if I wanted to find the 100th term in any of those sequences, I would not want to use the recursive formula, because I'd have to find the first 99 terms, and then I'd find the 100th term. And that would take too long. I don't want to do that. So the explicit formula, that allows us to jump and give any value for any term in the sequence. Okay, so we can find a 100th term just by putting 100 in for n. Or we can find the 50th term by putting 50 in for n. Now this is the way that the book sets up the formula. Personally, I do not like this format. You'll see why in just a little bit. This is what I would encourage you to do. So I would write it down like this. Constant difference times n minus 1 plus our first term. So again, the common difference would go here. And then this would be our first term. So I would write it in that order. So otherwise, if you write it like the way that they have it, if we had a first term of 4 and a common difference of 3, what I don't want you to do, because this would be wrong, I don't want you to add those together. That would not be correct. Okay. Instead, we would put it much easier to put the 4 at the end, so that way you don't make the mistake of adding the 3 and 4 together. And we could just leave it like that. All right, so let's look at those examples again. So again, we're going to do these together. So the first step is to figure out, well, it's pretty obvious what our first term is 4. The next step is, after we've already established that it is an arithmetic sequence, these are increasing by 10. So our common difference here would be 10. So our explicit formula we would say a sub n equals our common difference, which is 10 times n minus 1. Now, to differentiate, this n minus 1 that we saw here is a subscript. Okay, it's down below. Like if you were to think of it as writing on a line back when you had your, maybe they did this in preschool for you when you're learning to write, we would put that underneath that line, kind of contrary to what you would have learned in elementary school. It is not on the same level, so don't write it like that. That is wrong. Okay, so, but now what we're doing though, this n minus 1 here, that is at the same level. So that would be, n would be a variable. And then our first term is 4. So that'd be your explicit formula. You can leave it like that. Now, if they ever asked you to simplify it, you would simplify it by distributing the 10 through to the parentheses here. So we'd have 10n minus 10 plus 4, and then combine like terms. So negative 10 plus 4 would be negative 6. So depends on, so if it says to simplify it, then we would simplify it to get this answer. If it doesn't say anything about simplifying it, we could leave it in that form. All right, so let's look at the next one. So the next one, again, clearly the first term is negative 3. The constant difference, though, going from negative 3 to 2, maybe it's hard to see. But from 2 to 7, we're adding 5. 7 to 12, we're adding 5. 12 to 17, we're adding 5. And sure enough, negative 3 plus 5 is also 2. So our common difference is 5. So our explicit formula would be a sub n equals our common difference of 5 times n minus 1 plus our first term, which you can say plus negative 3, or we could just write it as minus 3. All right. So these we're asked to alternate between, if they give us the recursive formula, we want to write the explicit formula and vice versa for the next example. So let's look at this first one. So the things that I want to pull out of there is what's my first term. So our first term is a sub 1. By the way, if you notice, they don't say a sub 1 equals 3. Sometimes they will, sometimes they won't. So if they don't do it, that just means that the first row, the top number there represents the first term. Okay, down below here, we could see that our common difference is 0.5. So in writing my explicit formula, I would say a sub n equals, and then we would have our common difference, which is 0.5. You can use a fraction or a decimal, times n minus 1 plus our first term, which was 3. Now this last one, or this next one, they give us the explicit formula. We need to come up with the recursive formula. And like I said, with this explicit formula, they have it in order. It's not wrong, but it's just not what I think is the easiest. Because again, a lot of mistakes happen with people subtracting 16 minus 3. If it says to simplify it, they take 16 minus 3. That is wrong, because order of operations tells us we have to multiply first. We'd have to distribute this first, which we aren't going to do. But I'm just going to rewrite this as negative 3 times n minus 1 plus 16, because that negative applies to the 3, not the 16. 16 is positive. All right, so we want to come up with the explicit formula. Okay, if you're wondering what's the fancy bracket, you can start with the recursive formula with that fancy bracket. And then the top row, we can say what the first term is if you want. Write it like this. Our first term was the 16. And then we would have our previous term plus our constant difference. So you can say plus negative 3, or just write it as minus 3. Okay. I want you guys to try these next two on your own, and then we will almost be done with this video. So pause the video when you're ready to check to see if you have the correct answer. All right, so for this one, we see that the first term is 45 and the constant difference is negative 2. So the explicit formula, start with our constant difference of negative 2 times n minus 1 plus our first term, which is 45. And then the last one, and if you might be wondering, wait a minute, I don't know if I should write it like the way that you did previously, or should I write it like this? It's no big deal. There's a lot of different ways that we could set up our recursive formula. They all would mean the same thing. So if you want to write it like this, the way that it's showing, you can do the same thing. We are not super picky as long as it's clear that you have two rows where the top row identifies what the first term is. And if you wanted to, you could rewrite this with that plus 1 over here. 7 would be positive, so we're just going to write it like that. So now we could see our first term would be 1. And then we would take the previous term plus our constant difference, which is 7. So if we want to write it like that, that would be fine. All right, so let's look at a story problem together, and then I'll have you guys do the last story problem on your own. So here it says a high school auditorium has 18 seats in the first row and 26 in the fifth row. The number of seats in each row forms an arithmetic sequence. What is the explicit definition? Now, the hard thing is we know that the first row is 18 students, the fifth row is 26. I don't know the constant difference, but we can use something to find the constant difference. Now, the first step I want to do is I want to go back to when I simplified this one problem, this one. So if you recognize that's a linear equation in slope-intercept form. And the slope for that is the 10, which if you notice is also our common difference. So the common difference, so all of these arithmetic sequences, if you were to graph them, would be linear. And the slope would be identified by the common difference. So what am I getting at? We don't know the common difference here. But if I recognize that what they gave us here, the fact that in the first row there's 18 seats, and in the fifth row there's 26 seats, we can use those as coordinates and find the slopes. Remember the slope formula. We take y2 minus y1 over, x2, erase that, x2 minus x1. That finds a slope, but that's the same as your common difference. So we're going to take 26 minus 18 over 5 minus 1. 26 minus 18 is 8, 5 minus 1 is 4. Divide those, I get 2. So my common difference would be 2. And we know the first row has 18 seats in it. So we have everything that we need. So we would say, explicit formula, common difference is 2 times n minus 1 plus our first term. There are 18 seats in the first row. So now if it says how many seats are in the 12th row, so what I'm going to do is I'm going to replace n with 12. So technically, that means that this n and this n would be replaced with 12. That first n just means that we're finding the 12th row. So it just helps us see what we're trying to find. We're not going to actually do anything with the left side. We're just going to simplify the right side. So on the right side, we'd have 2 times 12 minus 1 plus 18. Which if we simplify that, obviously 12 minus 1 is 11. And 2 times 11 is 22, and 22 plus 18 is 40. So we know in the 12th row there would end up being 40 seats. All right, I want you guys to apply that same concept for this problem here. Now, when you go to find your slope, do not use the decimal form. Fractions are more precise, so leave your slope as a fraction that's been reduced, if it can reduce. So go ahead and try this one on your own and hit play when you're ready to, and so hit pause and then hit play when you're ready to check to see if you've done it correctly. All right, so let's think about what our coordinates are. So Samantha's training for a race. The distance of her training runs form an arithmetic sequence. She runs 1 mile the first day. So we're always going to have our days be our x, our independent value, because the y, the dependent value, depends on what day we're on. So on that first day, we're going to run 1 mile. And on the 7th day, she's going to run 2 miles. Okay, so the order that we put those coordinates is very, very important. All right, so now let's find the slope. So the slope, we would take 2 minus, or the common difference is the same as the slope. So we take 2 minus 1 over 7 minus 1. 2 minus 1 is 1. 7 minus 1 is 6. 1/6 can't be reduced, and leave it as 1/6. So our common difference is 1/6. And our first term was just 1 mile. So when it says, how far did she run on day 19? So now what we're going to do is we're going to put 19 in for n. So on the 19th day, I'll take 19 minus 1 plus 1, or 1/6 of 18 plus 1. 1/6 of 18 is 3, because 18 divided by 6 is 3. So we'd have 3 plus 1, which would equal 4. So how far did she run on day 19? It would be 4 miles. So hopefully that makes sense now, and good luck as you work on your assignment.